Hello, geometry students, and welcome to topic 6, which is on quadrilaterals and other polygons. So we're going to start off with section 6.1, which is related to the polygon angle sum theorems. So in example 1, we're going to come up with a formula to calculate the interior angle sum of a polygon. So how does the number of sides of a convex polygon n is the number of sides, relate to the sum of the measures of its interior angles? So if we take a look at some examples, we know the triangle has 3 angles, 3 sides, and we know that the angle sum for any triangle is 180 degrees. So if we take other polygons, like a quadrilateral, and divide it into triangles, then we get 2 triangles in the quadrilateral. If we continue on with the pentagon, which has 5 sides, drawing from one vertex, if we draw in as many diagonals as possible, remember a diagonal goes to a non-adjacent vertex, we end up with 3 triangles. In the hexagon, we have 6 sides, 6 angles, we end up with 4 triangles. Are you seeing the pattern? For 7 sides, we end up with 5 triangles. Okay, this is the heptagon. So, hopefully you've seen the pattern. There are 2 less triangles than there are sides, right? N minus 2 triangles in every n-sided polygon. Each triangle has an angle sum of 180 degrees. So our polygon interior angle sum theorem says that the sum of the measures of the interior angles of a convex n-gon is 180 times n minus 2. The corollary to that theorem says that the measure of an interior angle of a regular n-gon is 180 times n minus 2 divided by n. If it's a regular n-gon, regular means that all sides are the same length, all angles have the same measure. So once we get that sum, we divide out by how many angles we have, and that gives us one measure of an interior angle of that regular n-gon. Okay, so what I'd like you to do is try these problems for example 2. Okay, you've got 3 on this page and 1 on the next page. So pause the video, try these examples. When you're done, come back and we'll compare solutions. Okay, let's see how you did. So Jenna is building a corner cabinet to fit in a rectangular room, right? So she needs this back angle to be 90 degrees. So how will she determine if it will fit? The first thing we need to do is calculate that interior angle sum, which is 540 for a pentagon. And then if we subtract the angles that were given, we end up with 90 degrees. So yes, it will fit. The interior angle sum of a 17-gon, hopefully you came up with 2700 degrees. And then for part B, each angle of a regular n-gon measures 172.8. How many sides does the n-gon have? And hopefully came up with 50 sides. On the next page, let's see, the school zone traffic signs outside your school building have 3 right angles and the other 2 angles are congruent. So find the measure of the other 2 interior angles. So we need to calculate that sum. Again, it's 540 for a pentagon. And then if we have 3 right angles, that's 270 degrees. Subtract that, divide by 2, and hopefully you got 135 degrees. Example 3, understanding the exterior angle measures of a polygon. So what is the sum of the exterior angle measures of a convex polygon? So you can use what you know about the sum of the interior angle measures to find the sum of the exterior angle measures. So one side of the polygon and the extension of an adjacent side form an exterior angle. Right? So we can extend a side. So angle 1 is exterior. All of these numbered angles are exterior angles. Each interior and exterior pair form a linear pair, which measures 180 degrees. So the sum of the measures of n interior and exterior angle pairs is 180 times n. Okay, so if we take the sum of the exterior angle measures, we can set that equal to the sum of the interior and exterior angle measures and subtract the interior angle measures. So again, we said the sum of the interior and exterior is 180 times n. We know that the sum of the interiors is 180 times n minus 1. And then with some algebra, we come up with the fact that the sum of the exterior angle measures of any convex polygon is 360. So that's a very useful thing to know. That can make a lot of problems much simpler. It's often easier to work with the exterior angle measures than the interiors because of the fact that we know that it's always equal to 360 for any convex polygon. So theorem 6.2, the polygon exterior angle sum theorem, says that the sum of the measures of the exterior angles of a convex polygon, one at each vertex, is 360 degrees. So what is the sum of the exterior angle measures of a convex 17-gon? I don't even have to do a calculation. I know it's 360 degrees. So again, pause the video. Go ahead and try these examples for example 4 and example 5. When you're done, come back and we'll compare solutions. Okay, let's see how you did. So you're given information about the angles and you're asked to figure out what is the measure of each exterior angle. So again, if we're talking about exterior angles, we know that sum is 360 degrees. We can take what we're given, set that sum equal to 360, solve for x, and then we can use that x value to come up with the measures. For number 4, we're asked what is the measure of angle 4. Hopefully you came up with 70 degrees. For example 5, you're asked what are the measures of the interior angles of the pentagon shown. So again, for a pentagon, we know the interior sum is 540. Combine your like terms. You should have gotten 90 plus 22x plus 10 is equal to 540. So x equals 20. And then hopefully you got these measures by plugging that x value in. And then lastly, the measure of each interior angle of a regular 100-gon is 3x plus 26.4. So the x value is 50. So if you have any questions about any of these examples, let me know in class. Okay, that ends this lesson. I hope you enjoyed it, and I will see you in class. Enjoy your day.